All right, guys, I wanted to kind of make a little short training video. This video here is about 7 minutes and 42 seconds long. What I want to do in the time that we're not together, I want to take some time, make some short videos that you guys can watch on an honor system. I'll upload them to our YouTube for the fire department, and then I'll share them in the chat. This way we can get a little bit of training done whenever we're not together, and then we can focus more on the hands-on training. This is something that I saw the other day and I thought I needed to share with you guys, and it's about pushing fire. Historically in the fire service, we thought that we would push fire if we did not attack the fire from the unburned side. That is not the case really in pushing fire. What we were doing was pushing heat and smoke and superheated gases by not using the correct hose stream and water application on the fire ground. That's what that's going to go through. Here, I may pause a couple times and make some explanations, but I'm going to let Mr. Majkowski do his thing here and kind of explain the results of the testing they did.
Many firefighters have been taught that all hose streams can push fire. Therefore, you must always fight fire from the unburned side. Some firefighters have even experienced fire being pushed on them. But what does pushing fire mean? Pushing fire. When fuel gases hot enough to burn are displaced or pushed by pressure from an oxygen limited fire compartment to a space with oxygen that mixes with the hot fuel gases and results in combustion. What conditions do you need to push fire? Well, typically you need a ventilation controlled fire in a flow path that has intake and exhaust vents. Then you need a pressure source to create the push. In addition, you need an area on the low pressure side that has oxygen available for combustion. If you do not have these conditions, you cannot push fire. The pressure source could be from the wind, a fan, a fog stream, or a solid stream on a hand line that's being whipped around. If you review our research studies, we've conducted studies with each of these sources of pressure, and you'll see that even a small increase in pressure can drive hot fire gases through a space at speeds ranging from 6 miles an hour to greater than 20 miles per hour. There are situations where firefighters may want to use this push to their advantage when fighting a fire. Working with ISFSI and the Spartanburg Fire Department, we set up some tests to demonstrate pushing fire and also to show how it is important to choose your hose stream wisely and use it effectively for times when you want to avoid the push, the buildup of pressure. This video shows a post-flashover room fire in the rear of the structure. The rear room window is serving as both an intake and an exhaust vent for the fire room. The middle room is connected to the fire room by an open doorway. The middle room is also serving as an exhaust-only vent because the windowsill height is above the neutral plane. Note that the exhaust gases have enough heat and fuel to burn, but they don't mix with enough oxygen to burn until they are above the eave line. The fog stream is going to minimize the water entering the fire room, maximize the air entering the fire room, and provide the air pressure needed to push.
All right, so you saw clearly, plain as day, what happened there. They opened the hose stream up. They had a fog pattern. They're throwing that fog pattern in through that open window. And when they do, naturally, what a fog pattern does is it creates a vacuum, basically. Anytime, and we will test this out when we do some hose stream work and moving with hose, we're going to put a combination nozzle on. We're going to charge the line. I'm going to have you guys open it up, and I'm going to have you fog the pattern out. You will be able to feel, if you stand there, you will feel the air rushing from behind you because that's creating an area of high pressure to low pressure, and it is sucking that air through. Whenever you put that fog stream in an open window, it's taking all that air from the outside and it's pushing it into that space, which is already high enough pressure. And you saw the smoke, the superheated gases, the fire that got blown out of that other window. Imagine you're in that other room. Imagine a victim is in that other room. That's all going to get pushed onto them. That's why it's important that we choose our hose streams wisely when we're doing interior fire attack. In the next part of the video, they're going to show the actual proper application and another improper application of water from the outside. What we would normally consider like a transitional attack, where we cool the fire from the outside, and then we would send a team in on the interior to go ahead and extinguish the rest of the fire that we couldn't get when we put water from the outside. It's really important that we understand that the tactics that we use will affect not only us if we are inside that residence, but any potential victims that may be down. You will affect them as well if you take the application of water and you do it incorrectly. All right, so I want to make sure that that's kind of what we're understanding out of this, is there's more than one way to put water on a fire, and given the situation that you may be in, one way may not be the best. You may have to choose another way to put water on the fire that's not going to negatively affect both us, the firefighters, but first and foremost, the victims that may be trapped inside of that house.
Let's look at another experiment. Here we have two rooms on the second floor of a house. Both rooms are similar in size and had similar fuel loads, consisting of a wood bed frame, mattress, box spring, wood dresser, and pallets. The interior finish of the rooms in the connecting hallway at the top of the stairs consisted of wood paneling and oriented strand board on the walls, gypsum board and OSB on the ceiling, and wood flooring. The open doorways from each bedroom are opposite each other at the top of the stair. The doorway to the exterior at the bottom of the stairway is open. The cameras are located in this doorway looking up the stair. This door will serve as an air intake for the fire upstairs. The upstairs windows are the only point of exhaust initially in the fire, as the smoke building in the hallway does not have enough pressure to push all the way down the stairs against the intake flow of the air. The beds in both rooms were ignited at the same time and the fires began to develop. When both rooms had reached the fully developed fire stage, based on the available ventilation, gas temperatures near the ceiling were in excess of 1,000 degrees Fahrenheit, and the command to initiate water flow was issued. On the right-hand window, 150 gallon per minute straight stream was flowed. The straight stream was deflected off the ceiling to cool the gases in the room. The straight stream was then applied with minimal movement. This stream choice and nozzle handling technique maximized the amount of water entering the fire compartment, minimized the entrainment of air due to the hose stream, and kept the vent area of the window as open as possible to maintain the window as a low pressure exhaust vent. This allows combustion products and steam out of the window even though the line is flowing. The result? Little to no impact on the fire in the hallway at the top of the stairs, and a temperature decrease from the peak temperature at the ceiling in the right room from approximately 1,000 degrees Fahrenheit down to 300 degrees Fahrenheit. Next, a 150 gallon per minute fog stream, wide enough to cover the window, was flowed over the left-hand window on the second floor. The idea was to cover the vent, which minimized the amount of water that entered the fire compartment and increased the amount of air that was entrained into the fire compartment, and increase the pressure at the window vent, thereby blocking the vent.
So you guys saw clearly in that video, if anybody's on that stairwell, we have a team that's going to go up there. We're going to hit it from the outside. We're going to cool that fire down like they did on that right-hand side example. We throw water into that window. We're using a fog stream, or we're not applying that water, that hose stream properly, whipping it around, or we're using a fog stream. Anybody going up and down those stairs, they're going to steam like a lobster. I'll just be perfectly honest with you. It's going to be pretty bad. Then, first and foremost, though, what if there was a victim at the top of that staircase that was trying to make it out of that residence? They got overcome with smoke, they hit the ground, or they're just seeking shelter on the ground awaiting rescue, and we do that to them. we throw that hose stream in there and we push smoke, superheated gases, and hot steam on top of somebody like that. They have no protective clothing. They have nothing protecting them at all. We can do a lot of harm while we're trying to do good by using the wrong tactics. That's why I'm so passionate about this stuff, is because I want us to use the right tactics for the right situations. It's just like a football game. You got to have your defensive and offensive lines in sync, on whatever side of the field that you're playing on, or the other team, the fire, is just going to walk all over you. Okay. It's going to do what it wants to do. Fire is a living, breathing thing. It gives zero fucks about us. Okay. It wants to do its own thing. And we have to combat that. We have to be able to read that fire. We have to be able to know what tactics are going to be useful in certain situations and detrimental in other situations. That's why it's important that we're learning these things, get you guys to critically think, so that it's not just us officers on the fire ground like we're barking orders, or that we're being particular about a certain way that we want something done. We want you guys to understand from our perspective, we want things done in a particular way because it can negatively affect people if we do them the wrong way, if we're not aware of how our tactics and how we're going to play will affect everything else on the field. That fire is our field. That's where we go. That's where we put our fight up. Okay. So I'll let the video finish through and you guys can see for yourself. He's got some more good information. He'll just kind of clarify more on that.
Initially, this caused a surge of heated gases and smoke to be pushed down the stairs, as well as an increase in temperature in the fire compartment. As the fog nozzle was moved forward, more water began to enter the compartment and the temperature began to decrease. The fog stream created a higher pressure area at the window, effectively turning the exhaust vent into an intake. This added extra air for combustion, and it was an ineffective amount of water. In other words, not enough to cool the fire compartment, and therefore it converted to steam. This combination increased the pressure in the fire room and caused a quick burst of heat and flame to push down the stairs. When the fog stream was narrowed and moved forward, more water entered the fire compartment. The pressure at the window reduced. Cooling the fire reduced the pressure created by the fire itself and caused some of the fire gases to contract. As a result, the high pressure push stopped. So we've shown that you can push fire with a hose stream if the air from the stream creates a higher pressure area and the lower pressure area has oxygen available for combustion. However, we can also see that this can be prevented by the use of a solid or straight stream with limited movement if you're attacking from the exhaust side. If you're working in the interior and attacking toward the exhaust, you may want to use air pressure to your advantage to force heat away from your position and out another exhaust vent. Basically, it's all a battle of the pressures, pushing fire. When fuel gases hot enough to burn are displaced from an oxygen-limited compartment to a space with oxygen that mixes with the hot fuel gases and results in combustion. Please see our studies on ventilation, positive pressure ventilation, and fire attack so you can get a better understanding of the pressures created by a fire inside a structure, the impact of wind, the impact of fans, and the impact of hose streams, so you can make good choices on the fire ground.
All right, guys. So what I want you guys to get in your heads and think about is the tactics that we use. And this pushing fire was a very good example. I want you guys to understand that the decisions that we make on the fire ground will impact how successful we are. That is our job. We want to save life first and foremost. We want to save property. Again, if we go in there and we just start throwing water willy-nilly and we're not thinking about the impact that we're going to have and the way that we're putting water on the fire, we could affect that life part, that number one priority. We could negatively affect that. We don't want to do that. I wanted to clarify on one of the things he said there at the end. about smoke mixing. When we saw the video where the smoke came over the eaves and then the flame from the fire coming out of the window next to it caught the smoke on fire. If you're in a structure and you have that hot superheated gases and smoke and they're coming over the top of you, you have to cool that down before you make any advancement towards the seat of the fire. And the reason you have to cool that down is if that smoke gets over the top of you and behind you and it reaches its flammability range and lights off, you can have fire above you and behind you. And obviously you're going to have fire in front of you because you're advancing towards the fire. But if it gets over the top of you and behind you, that puts you in real danger. Okay. That's one of the indications, the pre-indications of flashover is when we get that turbulent smoke over the top. And then what happens is the flames start lapping out from the seat of the fire and they start rolling over in that smoke. And that's called rollover. Okay. You have to cool those superheated gases down. In the old days, they talked about, you're wasting water, you're putting water on smoke. What we realize now is when we're putting water on smoke on the inside of a structure, when we're advancing towards the fire, we are cooling those gases down to where they will not light off in above us and behind us and cause us to get injured or killed. Okay. Obviously, no one wants fire behind them. We want to attack and be able to see what we're attacking because it can't sneak up on us. But you can get yourself in real trouble if you don't apply water correctly. And that includes throwing a fog stream in a window and overpressurizing a room, and also not putting water on hot gases and smoke when you're advancing to the fire until it's too late. So this is just a quick video, and I wanted to give you guys some food for thought. Get your brains working, and then we are going to work hands-on the next time we have a training meeting, more on hose streams, on hose line advancement. My plan is that we take an engine down at the school because no one's going to be up there, and we may not pump off of an engine, but we may hook the hoses to the fire hydrant and just run the pressure off of those, and we can practice our hose advancements there. All right, so that way we don't have a lot of cleanup to do. If we catch a fire, we're not pulling hose off of our truck and we're scrambling around. We can just hook some extra hose and some of our nozzles to the fire hydrant and use it that way. And I think that would be a better use of our time and of our equipment. So I appreciate you guys watching this. If you do watch this video in its entirety, go ahead and let us know. Like I said, it's an honor system. Don't be a dick. Don't just say you watched the video if you didn't watch it. Put the effort in, and just watch the video and take the time to learn something. And I guarantee you in the long run, you will be thankful that you did, because it will make a difference. All right. Thank you guys again, and I hope you guys have a good rest of your day.